Hello, this is the section 6.3 lesson. In this section we're going to talk about the granddaddy of all operations, long division. Now we could spend all semester talking about long division, but in this short section we're going to just hit the high points, the most important points of what's going on with long division. So let's start off with a couple of quick examples to remind ourselves on how long division works, and then we'll talk a little bit about why this works. So let's take the problem 53 divided by 4. And so this is one notation that we can use to write division. When we do long division, we typically use another notation that looks like this. We draw our division symbol, we put the first number there underneath it, and the second number outside. And so now we look at the first digit here underneath our long division symbol and we say, well, how many times does 4 go into 5? Well, obviously it goes in there once. And so now we take 1 times 4 and we write the result underneath it, 4, and then we subtract and we get 1. Okay. And now the next step is to bring down the next digit, 3. So now we ask ourselves, how many times does 4 go into 13? And the answer is 3. And so now we take 3 times 4 to get 12. Write that underneath there. We subtract and we get 1. And then we'll just stop right there and say that the answer to our problem is equal to 13 with a remainder of 1. So that's all there is to do in long division. Let's do another little more complicated example. 131 divided by 3. And so let's write this in our standard long division notation. We're going to put the 131 underneath the division symbol, the 3 outside. And so now we say, well, how many times does 3 go into 1? Well, it doesn't. So then we say, well, how many times does 3 go into 13? Well, 3 goes in there 4 times. Now we take 4 times 3 and we get 12, and we subtract and we get 1, and then we bring down that 1, and then we say, how many times does 3 go into 11? And well, the answer is 3. And so now we're going to take 3 times 3 and get 9. We're going to subtract that and get 2. And then we'll stop right there and say that our answer is equal to 43 with a remainder of 2. So hopefully that refreshes your memory on how to do long division. Now, when we're doing long division, there's several questions we might ask ourselves. First question, what are we really doing when we're doing long division? Why would we do long division in the first place? Maybe the second question is, why does this work? Third question, why do we subtract? And even more than that, why would we multiply numbers? Why do we write numbers on top? Why do we write numbers on bottom? Why do we subtract them? Why are we doing all these different operations just to do a division? And then the fourth question, what does it mean to bring down a number? What are we really doing when we bring down a number? Well, we're going to try to answer all these questions here with a few examples. And we're going to draw pictures to help illustrate the answers to these questions. So first thing is we're going to review some ideas from back in chapter 1, and that's the idea of the place value system. So let's take a number like 64 and remind ourselves what that number 64 means. The 4 is in the ones digit, so that means that we've got 4 individual objects, and the 6 is in the tens digit, which means that we have 6 bundles of 10. And so if we drew a simple picture of this number, we'd have 6 bundles of 10. Maybe we'll just draw that as a simple little rectangle. So 1, 2, 3, 4, 5, 6. So there's my 6 bundles of 10. And then we've got 1, 2, 3, 4 individual objects. And so here is a picture of that number 64, dealing with bundled objects and then individual objects. Now let's take the number 247 as another example. The 7 is the ones digit. That means we have 7 individual objects. This is in the tens digit, so we've got 4 bundles of 10. And the 2 is in the hundreds digit, so that represents 2 bundles of 100. So to draw a picture of this, we'd have 2 bundles of 100. Maybe we'll draw that as a big box like this. 2 bundles of 100. And then we've got 4 bundles of 10. So 1, 2, 3, 4. And then we've got 7 individual objects. So 1, 2, 3, 4, 5, 6, 7. And so there's a picture of that number 247 using bundles of objects. Now we're going to use pictures like this when we talk about why the long division algorithm works. So our next example, we're going to set this up with a word problem, and then we're going to solve this word problem using long division and use the context of this word problem to describe why our long division algorithm works. So 131 popsicle sticks are to be divided equally among 3 cups. How many sticks will go in each cup? Well, first thing is let's draw a picture of this, kind of like what we've done in the past couple of sections. We've got 131 popsicle sticks. We're going to put some into the first cup, some into the second cup, some into the third cup. The question is how many sticks are going to go into each cup. And so from this simple illustration we see that this is a how many in each group problem. That's going to be solved by taking the number at the top, dividing it by the number of groups that we have in the bottom. And so our answer to this problem is 131 divided by 3. Now we've already done this calculation, but let's kind of redo the calculation and draw some pictures to illustrate what it is we're really doing when we did this calculation. So I'm going to start off here with the blank page. And first thing is over here I'm going to write the problem that I'm trying to do. 131 divided by 3. Now next I'm going to draw a picture of my 131 popsicle sticks, just like we did back in chapter 1. So 131 popsicle sticks means that I've got one bundle of 100 popsicle sticks. I've got 3 bundles of 10. 1, 2, 3. And then I've got one individual popsicle stick. Now we're going to take those popsicle sticks and divide them evenly among 3 cups. And so I'm going to draw 3 cups down here. 1 cup, 2 cups, 3 cups. Okay? So you want to take all these popsicle sticks and divide them evenly among my 3 cups. Well, I want to do this as quickly and efficiently as possible. So that means I want to start with my biggest bundle of popsicle sticks, namely this bundle of 100 over here. So I ask myself, well, how many bundles of 100 can I put into each cup evenly? Well, that's kind of like what we did over here in a long division algorithm. The first thing we did was we looked at the 1 and asked ourselves how many times does 3 go into 1? Well, the answer is I can't distribute this bundle of 100 evenly among the 3 cups because I don't have enough bundles of 100. So what I'm going to do here is to unbundle this bundle of 100. So I'm going to take this bundle of 100 and I'm going to break this down into 10 bundles of 10. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I'm going to cross off that bundle of 100 to indicate that I've unbundled it. So we unbundled this bundle of 100 to get 10 bundles of 10. Well, now look at what we have. We've got a total of 13 bundles of 10. So that's kind of like what we did when we looked at this 13 over here in this number. So now we're going to ask ourselves, well, how many bundles of 10 can I put into each cup? Well, I can obviously put 4 bundles of 10 into each cup. So let's draw those 4 bundles in here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So there we go. We put 4 bundles of 10 into each cup. Now, let's go back over here to our long division algorithm and indicate that we put 4 bundles of 10 into each cup. And I'm going to do that by writing a 4 right above the tens digit. So this 4 in the tens digit means that I'm going to put 4 bundles of 10 into each cup. Okay. So now I've used several of these bundles of 10, and so let's kind of get rid of those bundles of 10. So I'm going to cross off 1, 2, 3, 4. There's the 4 bundles of 10 that I put into this first cup. and then I'm going to cross off another 4 bundles, 1, 2, 3, 4. That's the 4 bundles that we put here. And then I'm going to cross off 4 more, 1, 2, 3, 4. That's the 4 bundles that I put right there. So what I really did is I crossed off kind of 4 groups of 3. And so over here in my long division algorithm, what I'm going to do is take 4 times 3 and get 12 and subtract that, and I'm going to have a 1. And so what we did here is just illustrated the idea that we just got rid of 3 bundles of 4. So we got rid of 3 times 4, and so we got rid of 12 bundles of 10. We subtracted that, and now I've got 1 bundle of 10, and that 1 bundle of 10 is represented right there. So now I want to do something with this bundle of 10. Well, I can't do anything with it in its current form. I can't distribute that evenly among my 3 cups because I've only got 1 bundle of 10. So let's do this. Let's unbundle this in kind of the same way that we unbundled this bundle of 100. So what I'm going to do is I'm going to take this bundle of 10 and break it up into 10 individual popsicle sticks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so now I'm going to cross that bundle of 10 off to indicate that I've unbundled it. And so look what I have now. I've got 1 popsicle stick left over from my original group of popsicle sticks, and now I've got 10 more individual popsicle sticks. So I've got a total of 11 popsicle sticks. So I'm going to represent that idea over here in my long division algorithm by bringing down this 1 like this. So now I've got 11 right here, and that indicates that I've got 11 individual popsicle sticks left. So now we want to distribute those 11 individual popsicle sticks evenly among my 3 cups. I asked myself, how many popsicle sticks can I put into each cup? Well, I could put 3 into each cup. So I'll put 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So let's indicate that over here in my long division algorithm by putting a 3 there above the ones digit. So that 3 indicates that we put 3 individual popsicle sticks into each cup. Okay. Well, now I need to cross off those popsicle sticks that I just put into cups, so I'm going to cross off 1, 2, 3. That's those 3 popsicle sticks. And cross off 3 more, 1, 2, 3. That's those 3 popsicle sticks. And then we're going to cross off 3 more, 1, 2, 3. That's those 3 popsicle sticks. So I just crossed off 3 bundles of 3, and so I'm going to indicate that over here in my long division algorithm by taking 3 times 3, which is 9. I'm going to write 9 there, and I'm going to subtract that, and I have 2. And that 2 right there represents that we have 2 individual popsicle sticks left. And so there we go. 131 divided by 3 is equal to 43, remainder of 2. In terms of this problem, it means that in each cup I'm going to have 43 popsicle sticks, and we're going to have 2 popsicle sticks left over. Now let's look at a similar problem with just some slightly different numbers, again to illustrate how we can use pictures to explain what we're really doing in the long division algorithm. So 432 popsicle sticks are to be divided equally among 2 cups. How many sticks will go into each cup? Well, again, notice this is the same problem that we just did. It's just some different numbers. And so if I illustrate what's going on with this type of picture, I've got my 432 popsicle sticks. Some of those are going to go in the first cup, some into the second cup. I don't know how many sticks are going to go in each cup. So again, this is a how many in each group problem that's solved by 432 divided by 2. So let's do this arithmetic using the long division algorithm. We're going to draw a picture just like in the previous problem and kind of relate the two. So over here I'm going to draw my long division algorithm. I'll have 432 divided by 2. Now let's draw a picture of that number 432. So 432 means that I have 4 bundles of 100. So I'm going to draw 1, 2, 3, 4 bundles of 100. And then we've got 3 bundles of 10. So 1, 2, 3 bundles of 10, and then we've got 2 individual popsicle sticks. I'm kind of running out of room here, but I'll just write them right here. Okay. So there's a picture of that number 432. Now we're going to distribute those among two cups. So I'm going to draw my 2 cups down here. Here's 1, and here's 2 cups. And so there we go. Now we're going to distribute all these popsicle sticks among these 2 cups. And we want to do this as quickly and efficiently as possible. So we're going to start off by looking at these bundles of 100. Ask myself, how many bundles of 100 can I put into each cup? Well, obviously I can put 2 into each cup, so let's do that. There's 1 bundle of 100, there's a second bundle, there's 1 bundle, and there's a second bundle. Okay. So going back to our division algorithm, what we really did is we looked at the 4 and the 2, and we asked ourselves, how many times does 2 go into 4? And the answer is 2. So that 2 right there illustrates the idea that we just put 2 bundles of 100 into each cup. Notice how we write that above the hundreds digit because that represents 2 bundles of 100. Okay. So now going back to my picture over here, we need to illustrate the fact that we just used those bundles of 100. So I need to cross those off. So I'm going to cross off 1, 2. That's those 2 bundles. And then I need to cross off 2 more. 1, 2. That's those bundles right there. So what we just crossed off was really 2 groups of 2. So back in our long division algorithm, we're going to take 2 times 2 to get 4. We subtract that to get 0. So this 0 indicates that we have no bundles of 100 left. And we can see from our picture that's exactly what we have left, 0 bundles of 100. Okay. But now we need to look at these bundles of 10 and distribute those. So we've got 3 bundles of 10. In our long division algorithm, we're going to bring down that 3 to indicate that now we're working with these 3 bundles of 10. And so I asked myself, well, how many bundles of 10 can I put into each cup? Well, obviously I can put just 1 bundle of 10. So I'm going to put a bundle of 10 and a bundle of 10. So I'm going to put 1 bundle of 10. In my long division algorithm, I'm going to put a 1 there above the tens digit. Now in my picture, I need to cross off those bundles of 10 that we just used. So I'm going to cross off that one and that one. And so now in my long division algorithm, I need to take 1 times 2 to get 2. Subtract that, get a 1. So this 1 right here indicates that I've got 1 bundle of 10 left. So now I need to keep going. I need to do something with these extra popsicle sticks that are left over. I've got a bundle of 10 and still 2 1s. I can't do anything with this bundle of 10 the way it is, so I need to unbundle it. And so let's unbundle this. So we're going to break this up into 10 individual popsicle sticks. And so we've got there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I see that I've got 12 individual popsicle sticks. In my long division algorithm, I'm going to indicate that by bringing down this 2. So this 12 here represents these 12 individual popsicle sticks that we have left. Now I need to cross off this bundle of 10 there because I just unbundled it. And so now we need to distribute these 12 popsicle sticks evenly among my 2 cups. So I say, well, I could put 6 popsicle sticks into each cup. So let's do that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to indicate that in my long division algorithm by putting a 6 above the 1's digit. And so now in my picture I need to cross off those popsicle sticks that we just used. So I need to cross off 1, 2, 3, 4, 5, 6. There I just crossed off those 6. And then another 6. 1, 2, 3, 4, 5, 6. That's those 6 right there. And so I've used 12 popsicle sticks. I just crossed off really 2 groups of 6. So in my long division algorithm, I'm going to take 6 times 2 to get 12. Oops. To get 12, I'm going to subtract that, and I get 0. So this 0 indicates that I have 0 individual popsicle sticks left over, and that's exactly what we have. So this result tells us that each cup is going to get 216 popsicle sticks, We can see that from our picture. I got two bundles of 10, or excuse me, two bundles of 100, one bundle of 10, 6 individual popsicle sticks. This remainder of 0 tells me that I have 0 popsicle sticks left over. So let's just kind of summarize the important points of these last two examples. Number one, the numbers on the top of our division symbol represent numbers of popsicle sticks that we put in each cup. And so each digit goes in a certain place because each digit represents a certain number of bundles of a certain size. We put a number in the tens digit because it represents a bundle of 10. We put a number in the hundreds digit because it represents a bundle of 100, and so on and so forth. Number two, we subtract because we have used popsicle sticks. We put those popsicle sticks into some cups. We got to cross them off, indicate that we're done with them. And then the third point here is maybe the most important point, is that bringing down a number really means unbundling. That's fundamentally what we're doing when we bring down a number. We've got a big bundle that we don't know what to do with, so we're going to break it up into smaller bundles that we can do something with. So that's it for the section 6.3 lesson. Your assignment for next class is to read section 6.3 from the textbook. Now, the textbook is maybe going to go in a little more detail than what we did here in the lesson. It's also going to talk about another algorithm for doing long division called the scaffold method. We're not going to talk too much about that in class, so don't worry about that. But it's just another way of doing long division.